There are two special definite integrals I want to talk about. And the first one is integral from a to a of f of x dx. Realize we are going from the same thing to the same thing. We're going from a to a. So if you visualize it, we have a graph of f, and we are going from x equals to a to x equals to a, and we want to find the area of this line. And area of a line is 0 because it's not enclosing any space. So integral from a to a of f of x dx is always going to be 0. So if you see a problem, integral from 2 pi over 7 to 2 pi over 7 of cosine squared of x plus sine cubed of x minus tangent of pi x dx, you don't have to worry about this because you're going from 2 pi over 7 to 2 pi over 7. No matter what the thing inside is, this thing is going to be 0. So whenever you see the same thing repeated for the lower limit and the upper limit, the definite integral is going to be 0. Now let's look at the next one, which can be tricky. Integral from b to a, so we're not going from a to b, we're going from b to a. So let's say that's our graph of f, and this is a, and this is b. We know integral from a to b of f of x dx is the area under the curve. So integral from a to b of f of x dx is this area. But what happens instead of going from a to b, we are going from b to a. What are we going to get? And the answer is going to be negative. We're going to get negative of the area, negative of the integral from a to b of f of x dx. And the reason for this is easier to understand after I teach you the fundamental theorem of calculus. But for now, let's visualize it like this. Let's say we have a car. Let's say we have a car. It's not a very good car, but it's moving toward the right with velocity 2 meters per second. So after 1 second, it moved 2 meters. After 2 seconds, it moved 4 meters. After 3 seconds, it moved 6 meters, and so on. So let's plot our velocity and our time here. So our velocity is always 2 meters per second. And let's say someone asked you, how far did the car travel? Did the car travel from time equals to 0 seconds to time equals to 2 seconds? And you will say, since the car is going 2 meters per second, it has moved the distance of 2 meters per second times 2 seconds, or 4 meters. Notice that the seconds cancel out. And another way of finding this is by finding the area under the velocity curve from 0 seconds to 2 seconds. What I mean, if we are going from 0 seconds to 2 seconds and finding this area, what is this area? The area is what? We are going from 0 to 2, so the base is 2, and the height, because that's 2 meters per second, the height is 2. So the area also gets you 4 meters. So you can say the area under the velocity curve is equal to displacement, or how far the object traveled. Actually, displacement is a factor, so we have to also care about the direction too. But for our purpose, the area under the velocity curve is how far you went. And let's say someone asked you, V, how far the car traveled? How far did the car travel from time equals to 2 seconds to time equals to 0 seconds? So you're going backwards. Since from 0 seconds, if the pen starts to work, 0 seconds to 2 seconds, you moved the distance of 4 meters. If you're going from 2 seconds to 0 seconds, you're going 4 meters backwards, or negative 4 meters. So that's the reason integral from b to a of f of x dx is integral negative of the integral from a to b of f of x dx.